The next part is to set up the problem in the system coupling. Before that, you should update the fluent setup and as well as the transient structural setup. So right click on setup in the transient structural and click on the update. Now right click on setup in the fluent and transfer data to new system coupling. Also take the link from the setup in the transient structural and put in the setup for system coupling. And once again update the fluent and also the transient structural. Now double click on the setup to open the interface for system coupling. In the analysis setting, we will set the time, that is this the time step we set in the fluent or transient structural is uh, not used, but the time step we set here is going to be used. So we have decided the time step to be the 0.2. So put the time step, end time is 20 seconds. Time step is the 0.2. Keep the minimum and maximum iterations to the 1 and 5. The next thing is to define the participants for the data transfer. So participants are going to be the boundary where we have the interaction between the CFD and the transient structural. So this boundary is basically is the sphere boundary. So just select the both boundaries. Just hold the control key and click with the left mouse button and select the both boundaries, which is the sphere in the fluent and the fluid solid interface in the transient structural. Then right click anywhere on the sphere or on the fluid solid interface and click on the create data transfer. So you will observe that the two data transfers are formed. One is for the fluent, region is sphere, and variable which is going to be output is the force, and the target is transient structural, and the boundary where this force will be transmitted is the fluid solid interface, and variable is force. The second one, that is from the transient structural to the fluent, and here the variable which is going to be exported from the transient structural to CFD is the displacement. So we are almost done. So now click on the update. This will open the one graph where the data transfer uh, between the CFD and the FEA. Uh, this will show you the convergence of the data transfer between two applications. So first, few important things you should note here. Number one thing is that the mapping should be the 100% between CFD and the FEA. So shortly it will show you the mapping summary. So we 100%, we have 100% here. So that's good enough. Everything 100%. But if the this value is less than 90%, then you should be worrying that the what wrong is there, and you should try to correct that thing. Now just wait, the solution will, it will start with the coupling iteration 1, 2, 3 and up to 5, and meanwhile you can also see what is happening in the fluent and also in the transient structural. So they are also solving in their own code, and the data is being transferred via the this data transfer we created for the sphere boundary, that is the boundary for FSI in the fluent, and the FSI boundary, that is the boundary for the data transfer in the transient structural. You can again check the system coupling. You can also insert the, in the chart you can also insert the more monitors as required. So here we have the transient structure data transfer change root mean square, and fluent data transfer to change root mean square. So you can put the some additional variable from fluent or from the transient structural. So let's say I can put here maybe x velocity in this chart. This will also be shown along with these two datas. So because it's not necessary to have this chart here, so we can just delete the chart from here. It's still a first coupling iteration. Now we have second coupling iterations in progress, and you can see the data convergence between the fluent and the transient structural. So because time step is 0.2, it means that the for 20 time, for the time of 20, it's going to take the around 100 time steps to get the flow from inlet to the outlet. But because the sphere is midway between the inlet and outlet, so time it will take is half. So number of steps also going to be the half. So it give you the reasonable solution within the 50 time steps. Anyhow, I will stop the solution after maybe 10 to 20 time steps to show you the data in the transit structure also as well as in the CFD post. As you can see, after 3 coupling iterations, and that is for the first coupling step, and the maximum allowed iterations within the one step are 5. So on third iteration, there's error in the transient structural. This shows that the sum of the nodes, one node 1387 has a velocity of this much. Okay, so the possible solution we can have is to reduce the time step by factor of 10. So, but for this thing, the everything should be at the zero at their zero location. So for this to happen, you should import the mesh again. So just export the mesh. Since the mesh has no displacement, so it will give you the very initial position at the time 0. You can update the fluent setup. Now for the transient structure to be at the 0 time step, the geometry and mesh should be a 0 time step. So just need to right click on setup and click on update upstream components and then click on update. Now double click on setup. In the analysis settings, change the time step to the 0.02 and then run the case. This will start from the scratch. So first we see the time step, the coupling step 1 and the number of iterations will be there. For each coupling step we have the 5 maximum iterations. So let's see what happens for this time step. As you can see, now we are in the fourth iteration, first coupling step but fourth iteration, and it seems that the solution is going smoothly. So just keep it running for maybe next 50 steps. You can also run the solution for the complete cylinder length, but for demonstration purpose we stop at some like 30 to 50 coupling steps to show you data and post process the data in the CFD post. So let's check the solution progress. So now it's at the 7th coupling step. So we will stop the solution at this moment, but you can continue solution. Since for the demonstration purpose, it's not required to complete the solution up to the end of the pipe. So we are just stopping solution here. It will take some time. It will complete the next 2 iterations. Meanwhile, you can see this solution in the fluent is running, and for transient structural you can see the displacement which is being transferred to the fluent. This is the receipt force from the fluent, Fx, Fy, Fz. The main force is in the z direction. This is summary for the run which has been completed now. So now just go to the project, and if you want to continue solution you can click on continue solution. It will continue the calculations. So now go to the project. From here go to the results here. You can evaluate all the results which you've defined before running the solution. So just right click on solution cell and click on the evaluate all results. To to display deformation. This deformation for this case is maybe a combination of the displacement as well as the deformation of body. But because since we didn't model the body in a way that it can deform because made of the steel, which has a very high modulus of elasticity, so it's not going to deform for this force. But all the force we are applying is basically is going to shift the body mainly in the z direction. So which you can see if you play the animation here. See little because time step is very small, so but still you can feel the ball is moving. This is the equivalent stress on the body. The maximum value is 2313 pascals. So shear stress. Okay, now go back to again to the workbench. Now we define the post processing in the CFD post. Also provide the link from the solution in the transient structural to the results panel. I now double click on the results. Here's a sphere from the CFD module, and here is a sphere from the transient structural module. If you want to display the mesh, you can do it by enabling the show mesh lines. Change the color to the black. Apply. And same goes for the transient structural boundary. So almost overlapping mesh from both sides. You can display the contour plots. Let's say pressure. Change the levels to 30. So here we have the stagnation point. So here we have the stagnation point, and you can also display the deformation. Okay, so this is the end of the tutorial. If you have any queries, please feel free to ask us at the given email ID, or you can reach us through the Skype, or you can ask on the YouTube. Thank you for watching.